The next thing we want to do is go ahead and set up those conditions for equilibrium that we talked about when we defined static equilibrium. So we're going to set up equations using those conditions for equilibrium. All right, so we know two things. We know the net force has to be 0. And so remember, we need to look at components. That means the net force in the x direction has to be 0, and the net force in the y direction, oh my goodness, too many squiggles, has to be 0. All right, so that's our first condition. We can go ahead and write a little more into this. Let's look at all the forces in the x direction. We have Fx and we have Tx. Let's call right positive. So Fx minus Tx has to equal 0. So that's kind of the first equation we get. I'm just going to make that look nicer. Fx minus Tx equals 0. And we could do a little rearranging. That means that the magnitude Fx has to equal the magnitude Tx. So if we know one, we know the other. And then we want to look at the net force in the y direction. And there's a little more going on there. Let's call up positive. So we have Fy and Ty. Fy plus Ty are up, but then both of the weights are down. So minus little mg minus big mg. And that sum has to equal 0 as well. And so for now, I'm just going to leave that one as it is, but it could come in handy later on. So that's our first condition. The net force has to be 0. The next thing we want to look at is the net torque has to be 0 because it has to be in rotational equilibrium as well. So the net torque has to be 0. Now here's what's pretty cool. We get to choose the axis of rotation because it's not rotating. So that means theoretically it could be rotating around any point. The net torque still has to be 0 around any point we choose. And so we're going to choose a location where we have unknown forces or maybe just forces in general, so that those forces will not contribute to the net torque, because remember, torque was RF sine theta, so it had to be away from the axis of rotation to cause a torque. And so I'm going to choose, since we don't know anything about the force on the bar from the wall, I am going to make my pivot point over here on this far left side. And so that means that Fx and Fy will not contribute to the net torque because the distance from the axis rotation is 0. And so then that means that only the weights, the weight of the bar, the weight of the sign, and the tension in the y direction will contribute to the torque because Tx is parallel to the bar, so it won't contribute either. So I'm going to go ahead and write out that equation as well. So looking at it, Ty would cause the bar to rotate counterclockwise, and both of the weights would cause the bar to rotate clockwise. So we'll use our convention that counterclockwise is positive, so the torque from Ty minus the torque from little mg minus the torque from big mg has to sum to 0. And so that is our second condition.